Hello. So it's good that I wasn't late again. So since we only need to return true or false, we can have a hash table. So n could be quite large, but it's okay. Because length is bounded by log, which is almost constant, so we can just brute force it. So we need a helper function to convert it into a string with a string of representation in an array. Okay, let's say key. And we want to return a list of ends. I'll skip this because I don't know the version. So this is done by, and since we want to test if it's symmetric, it doesn't matter which order we test. That was a very bad naming because it cost me plenty of time to type it. I want to have a sample of a true answer just to be certain. I think 3 is okay. I mean, 5, maybe. Whatever. covered by a set of columns of each cell and the rows. Okay, two obvious thoughts is like DP or greedy. So you start with the column that can increase the max amount of rows. That's the greedy. Plus the range. Okay, it's pretty small, so maybe it's like brute force. Let me look at this one first. So this seems to be a sliding window. We need a way to obtain like a running max within a sliding window. And we can modify this. Is that it? Like, how do we get the max in a running set? We can use like monotonic stack, whatever it's called. Okay, what about this? Do I write this first or this one? Maybe this one. So 2 to the 12 it'd be 4,000 something. It's okay. No, or this, or no. Number of columns you must choose, so like exactly calls. So that's actually like and choose calls. How do I generate all this? Okay, this looks like the thing that I want. And then X number of rows. So does it return a what? A tuple. So it doesn't mutate when I read it. Met if easier to write it this way. So for a row in a column set, INCS for IX. Wrong. Three and two. Okay. Covered by a set of it doesn't make any sense. Unless, no. It should default to true. If it doesn't, I'd be really disappointed. So what's the issue? So it gives 1, which means we come here, we came here. But then only one of the rows gives this. I was hoping like some Python 2 code could sneak in. That's a poor definition of any. What? Oh, right. It should be an all. I was stupid. That's pretty stupid. That all makes sense. Okay, so we have a sliding window here. Let me copy paste this so that I don't have to scroll up and down again. Consecutive robots. So if we want a running max, then the stack is like monotonically decreasing. It's not a stack, we need a DQ because we need to pop from the left. So like at each step, we inspect the left and pop like irrelevant things. And then also like the max is the leftist one. And when we append, we pop everything that's strictly smaller and append it. Or we can pop everything that's like, it doesn't really matter because we only want the max value here. And we need to have a running cost. And we have a start and end, or like, oh, I have ij already. So in the outer while loop, we increment j, and in the inner one, we increment I. Let's put an L here for simplicity. Because we want the longest, so we want to increment j first, and then when we like, when do we increment I again? When we exceed the budget, we increment I. So we want to append the current something seems weird. I'm bad at sliding window. Sorry. So maybe it's better to put I in the outer while loop. So answer equals 0. Do I need index? I need index. Let's name it rsum, it's simpler to type. And what else? Total cost TC. Funny. Close. So this is non-empty because we appended something here. So we break out of the loop either when so this L stands for no break, which means we've moved to the end, then it doesn't make sense to further decrease I. Otherwise, we're here, then we're like increasing I. Right? So like for every rand, if so basically, if the current cost after moving I is already too big, then we don't want to move J. So either I handle it here or I handle it here. Both are slightly annoying. So maybe I got the order wrong after all. Yes, I think I did. So maybe let me try this. Or not. Is it going to confuse me even more? No, it doesn't make any sense. So we're checking for the index of the leftist element in our monotonic stack. And if it's smaller than the new I, this oh, and apparently I forgot to increment J here. So we're in an infinite loop. What if we popped everything? Does it ever happen? So if there's, okay, if not stack. So in this case, that means like one single element already exceed the whatever, the budget. Then we cannot move I rightwards. Let's put L. Otherwise, we have a TC that equals 0 plus don't know what I was doing there. And when are we ever getting out of this, or are we done already? 3, 6, 1. It's like the first three. Why did it go to 4 and 5? So 0, 1, 2. Do I need a +1 here? I shouldn't. So I actually want this sum after incrementing j because we've moved it. Now it seems more reasonable. Try my luck. So initially we're at 0 and 0. Say we increase it to 1. Now we have one element here. So this is 1, this is 1. So what is wrong? So we're supposing that while like popping element from the left, we are handling the things correctly. So also it seems like this should be here instead of here. Wait. It's funny. Okay. And where else? Am I missing something in the end? 85. So I decremented the thing here. I was wrong. I was comparing value against index, which doesn't make any sense. And then this is the thing we want to pop. So anything smaller than or equal to should be popped. So now it's even more wrong. So I, J, D. We have 0, 1, 0, 2. I couldn't see whether this is correct or not. Huh? What is this? It's another test case. Okay, great. It's still slightly annoying and awkward that I had trouble implementing like sliding window. I should practice more on that. Why isn't it loading? Okay, not too bad, but again, we'll see like how many people will catch up within the next 10 minutes. Thank you.